The process of inserting the data into the queue is what I will call it as a enqueue. The process of removing or deleting the data from the queue is what I will call it as a dequeue. If I start removing all the elements from the queue, okay, so head can cross the tail. That's what you need to understand. Hello everyone, I welcome all of you to the yet another interesting session on queues. So guys, please don't forget to watch my previous session on queues because that's going to be the basic concepts and the basic session on queues. Only if you watch that, you will understand the session. So guys, without wasting much of your time, it's time for all of us to check what exactly that I have in the agenda for the day. So fine. So guys, I will be discussing 3 different types of queues along with, which we have already discussed the simple queues in the previous session. So guys, including that, we have these 3 different types of queues. So altogether, we have 4 different types of queues. So fine. So what is the first type of queue that I'm going to discuss in today's session? It's going to be about circular queue. Along with that, I will also discuss the other 2 different types. That's going to be the doubly ended queue and priority queue. So without wasting much of your time, let's get into the concept of circular queue. So guys, I have the definition here. Before I get into this circular queue, let me just give you a brief introduction or a recap of what exactly that we have discussed in the previous session with respect to the simple queue. So guys, simple queue in the sense, whenever I say the queue, so you need to remember, so this is a queue, okay? This is a beautiful queue. What type of queue? Beautiful queue. Whenever I say queue, so I will be inserting the data and I will be removing the data. That is what I will call it as the enqueue and dequeue. What is the meaning of enqueue? The process of inserting the data into the queue is what I will call it as a enqueue. The process of removing or deleting the data from the queue is what I will call it as a dequeue. So that is the thing that you need to remember. So fine. Now I need to remember 2 pointers. What is that? So imagine I have this, I will call it as a front pointer, and this I will call it as a rear pointer. This I will call it as a front pointer, and this I will call it as a rear pointer. So what is the speciality of front pointer and the rear pointer? Always the insertion of the data will happen at the end and deletion will happen at the front. That's what you need to remember. So I repeat, when it comes to the concept of queue, so always the insertion of the data will happen at the rear and deletion of the element happen at the front. That's what you need to remember. Sir, when it comes to the stack, so imagine this is a beautiful stack. So what happens in this stack? So guys, remember, deletion and insertion will happen in the same end, but in the queue, it will not happen like that. The deletion and insertion will happen in the separate ends or the different ends. That's what you need to remember. So fine. This is the basic concept that all of us know. So what happens here? What is the meaning of circular queue? So that's what we are trying to understand. So guys, let's understand the concept of circular queue. Hope you know this concept. So let's understand and study the concept of circular queue. So circular queue is also a linear data structure. What is the meaning of linear data structure? You will be storing the data one by one after the other. So that is what we call it as a linear data structure. Sequentially, if you are storing the data, so we call that as a linear data structure. So fine, even the circular queue is also a linear data structure. Moving forward, which flows the principle of first in, first out. First in, first out. The same thing happens in the simple queue also. So first in, first out. Say for example, I have inserted 10. Let me just give you a simple example. So all of us are standing in a queue for a ticket. Okay. So first I will enter the queue. Imagine I'm in the queue. So a lot of people are behind me. So imagine now I got my ticket and I will move out of the queue. So I have come first. So I'm going out of the queue first. That's what you need to remember. Okay, so 10 people are standing behind me. Okay, so before them, so I will move out first. I have come first and I will move out first. You just have to imagine the queue, what we go in temple, what we go for a movie ticket, wherever you find a queue, the same principle we are just following here. That's a principle that you need to remember here. Instead of ending the queue at the last position, it again starts from the first position after the last. That's what you need to remember. Sir, what is the meaning of it? So observe here. Imagine this is what I will call as a circular queue. So what is that we have done? So the same thing I have done. I have joined that. That's it. I have not done anything else. See, observe here. So I have joined this. So if I join this, I will get this circular. That's it. Okay, that's what you need to remember. That's a concept of circular queue. There is no special thing in the circular queue. Alright, so now it's time for all of us to understand how exactly it is working from the scratch, from the basics. Okay, so let's start with the first point what I have. So guys, in the case of circular queue, head pointer will always point to the front of the queue. So that's what you need to remember. So I was calling the front pointer and the rear pointer. So I will call this as a head pointer now. So what I will call it as head pointer. That's what you need to remember. Head pointer will always point to the front of the queue and tail pointer will always point to the end of the queue. That's what you need to understand. So fine, that is what the first point says. So fine. Initially, the head and the tail pointer will be pointing to the same location. So that's the first thing that you need to remember. What is the meaning of it? In the beginning, I have the empty queue. So where will my pointers, both the pointers will be? So it will be pointing to the initial location. It will be pointing to the initial location. That's what you need to remember. So fine, we understood both the things. What is the first thing? So it will have two pointers, head and tail, and both the pointers will be pointing to the same location. That is the initial location. That's the first thing that you need to remember. So fine, we understood that. Moving forward to the next point. So new data is always added to the location pointed by the tail pointer. And once the data is added, tail pointer is incremented to the next available location. So very beautiful thing. Observe, this is what I have. Okay, now my queue is empty. So where should I insert my data? So where my tail pointer is pointing, to which location it is pointing, so to that particular location I should add the data. Say for example, my tail is locating this location, I will add my data D1. So after this, after I insert the data into this location, what happens? My tail pointer will move to the next available location. That is what the point says. So that is what the point says. Observe here. Okay. So now the tail should move to the next available location. So head will be there itself as it is. That's what you need to remember. So fine, we understood this. Moving forward. What is the next point that we need to understand? So in a circular queue, data is actually removed from the queue. Only the head pointer is incremented. Observe here, this is very, very important. What happens? They are speaking with respect to the removal of the data. So what exactly they are trying to explain when they remove the data? Are they actually removing the data? That is what you need to concentrate and listen. I repeat my point to all of you. So this is my circular queue. They are speaking about how exactly they are trying to delete an element from the circular queue. So are they exactly deleting or anything else they are doing? That is what you need to concentrate. Listen to me carefully. In a circular queue, data is not actually removed from the queue. They are not removing from the queue. Observe. Only the head pointer is incremented by one position when the DQ is executed. What is the meaning of it? Observe. My head pointer was pointing here. Okay. Previously it was here. Okay. If I perform DQ operation, what is the meaning of DQ operation, which we discussed in the beginning of this session? DQ in the sense you are removing an element from the queue. So that is what we call it as a DQ. Always remember DQ in the sense deletion of an element will happen only in the front end. So always head pointer will point to the front of the queue. So that is what you need to remember. Wherever I have my head, that is what I will call it as a front end of the queue. So fine, here my head pointer was there. So if I want to remove, what I will be doing is, I will not remove the data. I will just move the head pointer to the next element. I will move the head pointer to the next element by incrementing it from one position. That is what you need to remember in this point. All right, that's how we are deleting, we are removing, we are unlinking this data element from the queue. Suppose if you ask me, after performing the DQ, what are the elements that we have in the circular queue if you ask me? So I will give you D2, D3, D4. That's it. I will not give you D1 because I have already removed it. I have unlinked it from the pointer. That's what you need to remember. Moving forward to the next point, the head and tail pointer will get reinitialized to 0 every time they reach the end of the queue. So once it comes to this location, automatically the initialization of that particular pointer will be 0. The value of the particular pointer will be 0, both head and tail. So that's what you need to remember. Sir, why are you saying this? Say, for example, most of my students have asked, sir, after performing one round, will they have the previous value? Say, for example, till here I have 8. Suppose if I come here, will it become 9? No. Once it reaches here, again the tail will become 0 and head will become 0. It will get initialized to 0, initial value. That's what you need to observe here with this point. So now the last point, okay, let's understand this. The head and tail pointer can cross each other. Imagine my tail pointer is here, okay? So can the head cross the tail? Yes, it can cross at one particular point of time. If I perform more number of DQ, you might think it is odd. How can head crosses tail, okay? But it can happen in the circular queue if I perform some certain number of DQ operations in the circular queue. If I start removing all the elements from the queue, okay, so head can cross the tail. That's what you need to understand in this point. So guys, I have taken some of the example to you. So what exactly that I'm trying to show you here is, observe here I'm performing NQ14. NQ14 in the sense I'm inserting 14 in this queue. So fine, I have inserted it. So my front and rear, that is head and tail, both are pointing to the same element. Now after that, so the rear will get incremented. Again I will perform 22. Okay, what is this 22? NQ22 in the sense I will insert 22. So fine. Now my front is pointing to 14. Observe here, and rear is pointing to 22. So fine. And then observe here NQ13. So NQ13 in the sense I will insert this 13 after 22. Alright, so that's a thing that you need to remember. Alright, so fine. NQ minus 6, where should I insert minus 6? After 13 I will insert minus 6. Observe here. So now DQ, I'm just calling that function. So which element should I DQ? Should I delete? Should I delete this minus 6? Or should I delete this 14 which is in the beginning? So that's what you need to tell me. So 14 we have removed. Okay. So this is an example just to show you how exactly insertion and deletion operation is happening. So basically the idea behind this example is just to show you so where exactly the deletion will happen, whether it is in the front end or in the rear end. That's what the idea behind this diagram which I have taken here. Alright, so fine. Again I am performing DQ. So after deleting 14, so what is the next element that I had? 22, which I am removing. Okay, so fine. So next NQ. So NQ, where should I insert? So after minus 6, okay, which I have inserted. Again NQ. So after 9, I will insert 20. So again NQ5. After 20, I will insert 5. This is how the NQ and DQs are happening. But at the back, whatever I have shown here, that's what you need to remember. Okay, head pointer, tail pointer. So when the insertion happens, so the tail pointer will move to the next available location. So which I have not depicted in this diagram. That's what you need to keep it in your mind. So whatever I have explained the concepts with this diagram, you need to follow this. All right, moving forward to the next one that I have, applications of circular queue. What happens with the applications of circular queue? Where can I implement this? As usual, I can also implement this in the managing the computer controlled traffic signals. Okay, so we can also implement this in the traffic signals. All of you would have seen that. Okay, that's again a circular queue. And then CPU scheduling and memory management, also we use this concept. All types of queues, generally when it comes to the applications of queue, all types of queues, we can use it for CPU scheduling. All right, that's what you need. And memory management. This is going to be a very important thing with respect to the disk management, CPU scheduling, and memory management. So all the schedulings we can implement with respect to these topics is what you need to remember. Moving forward to the next type of queue. When it comes to the doubly ended queue, what exactly doubly ended queue? What I explained in the previous concepts is all about, so observe, so I have written the queue like this, right? So what is this beautiful queue? So insertion, I have told you, remember, what happens? Insertion will happen in the rear end, observe here. So insertion will happen in the rear end and deletion will happen at the front end. That's what you need to remember. In the normal queue, even in the simple queue and circular queue, insertion will happen only in the rear end and deletion will happen only in the front end. But when it comes to the doubly ended queue, what is the meaning of doubly ended queue? Both insertion and deletion will happen at both the ends. That's a meaning of doubly ended queue. That's what you need to remember. That's the speciality of doubly ended queue. Rest everything remains as it is. All right. I repeat, insertion and deletion will happen in both the ends. So that's going to be the unique concept of doubly ended queue when we compare this queue with a simple queue. All right. Moving forward to the next queue that I have, priority queue. Very important thing that you need to remember. So even doubly ended queue also linear data structure. Priority queue is also linear data structure. But when it comes to the doubly ended queue, both the operations you can do it in both the ends. But when it comes to the priority queue, it's a very beautiful concept. Mainly we use this in the CPU scheduling again. So why are we using, if you have studied the operating system concept, you would have come across with this type of scheduling. We have a scheduling algorithm. So one of the algorithm is we use this concept for one of the algorithm. What is this? I have a processor and very important process which I want to execute, which is in the queue. So I don't want that particular process to wait in the queue. So instead of that, so I will give that process as the highest priority. So I will push that process to the processor and I will make sure that it will get executed. Then how do I do it? So that's what I'm going to explain with this. What happens is, so guys, observe, the deletion of the element, okay, will happen based on the priority. That's what you need to remember. So that's what you need to remember with respect to the priority queue. Let me explain this in detail. Listen to me carefully. When it comes to the priority queue, it's an extension of a queue with the following properties. Yes, all the properties of the queue even applies to the priority queue, but there are some extra features which we need to learn. What is that? Every item has got a priority associated with it. Whenever I insert any item, so that item has got a separate one more value. That is what I will call it as a priority value. So fine, that is the first point that you need to remember. Second point, an item with the highest priority is dequeued before any item with the lowest priority. You already have seen in the previous concept, always the deletion will happen in the front end. Observe, but here when it comes to the priority queue, always the deletion, that is DQ, will happen with the element which has got the highest priority, not in the front end. The element which is not in the front end is not removed. The element which has got the highest priority will be removed. How will I come to know about the highest priority of the element? So whenever I'm inserting the element, so that element will be associated with the priority. That is what you need to remember. That is the most important point that you need to remember with respect to the priority queue. So fine, if two elements have got the same priority, then what should I do, sir? So at that time, it will take the order. So at that time, it will take the order who has come first. So I will remove that from the queue. That is the point that you need to remember. And the next point, you need to remember in the below priority, observe here, in the below priority, the queue, elements with the maximum ASCII value will have the highest priority. Which element has got the highest ASCII value, that will have the highest priority is what you need to remember at this point of time. All right, so hope you understood the concept of priority queue. So guys, what are the different types of operations that I can perform with respect to the priority queue is what I've mentioned here. So you can insert an element. So whenever I'm inserting an element, obviously two things I have to insert. One is item and also I have mentioned that you have to insert the priority. So I've already told you an item associated with the priority is what I will be inserting. That's what you need to remember. And then, so I can perform one more operation, that is get the priority. Get the priority will give you the priority of that particular item. So this function will help me to get the priority. That's one thing you need to remember. And then delete the highest priority. So it will help me to remove an element which has got the highest priority. So that's what you need to remember here. And then applications, as I told you, you can also perform CPU scheduling, and also you can disk management, memory management. You also have one more important point, like the graph algorithms like Dijkstra shortest path. What is the meaning of this Dijkstra shortest path? Sir, can you please speak about this? Imagine I have the graph. Imagine like this. Okay, I have the graph. Okay, so instead of graph, you just have to think that this is a path. Okay, this is a path. From here to here, I need to travel. Okay, so let me just mention it as yes, and this is as a start. Okay, and this is as stop. All right, so let me just show you one more thing. Okay, 1, 5, 6, 8, 9, 10, 4, 2, 3, 4. Okay, so now what I will be doing is, imagine this is a graph. So I need to reach this location. What are the different possible ways that I have to reach this location? So that is what I will check. So one is I can come here, and I can come here, and I can come here. Okay, that is the first path. I can come here, and I can come here, and I can come here. Is it possible? No, I should come here. Okay, so this is the path that I have. This is the first path, and this is the second path. So you need to calculate the amount that I have. 1 plus 5, 6, 6 plus 8. So come on, how much? I'm very poor in the maths. 6 plus 8, come on, 14. So 14 plus 6, 20. 20 plus 4, 24. This is the total effort or the weight that I have, okay, to reach this element. But if I follow this path, so how much? So 1 plus 2, 3, 3 plus 4, 7, 7 plus 4, 11. So which path is taking very less weight? So the path number 1. So this I can say it as shortest path. Okay, this easily you people will be thinking, right, now shortest cut, no shortcut, no shortest path. So I will be able to calculate this shortest path using an algorithm called Dijkstra algorithm. Okay, so let me not explain that. I just try to give you an essence of it instead of just saying Dijkstra algorithm. So this is how we will be calculating the path. So in that, the algorithm will give me the shortest path. So even that algorithm can use this priority queue, is what they're trying to say. All the queue applications with the priority is involved, we can use this priority. So with this, I have come to an end of the concept of queues. So guys, happy learning. Take care. Bye-bye. With respect to the programs of this concept, I will be discussing that in the lab. So happy learning. Stay safe. Bye-bye.